again guys, we are the Einstein Lab Group number 10 and we are on the lab experiment number 6, the last experiment in this semester. And the title of the experiment is the parallel connected resistances. So watch till the end.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic?
Hi guys, this is PJ and today I'm about to present to you the objectives and the materials used in this experiment. So the objectives in this experiment is to verify the principles governing resistances which are connected in parallel, and the materials or apparatuses used in this experiment is the PhET simulator, specifically the Circuit Construction Kit TC. So once again guys, this is PJ, your cutie little Einstein number 1. Charot lang. So again guys, I'm here again because I'm the one who will be presenting the diagram. So now let us proceed in the diagram. So the following are the diagrams that we have captured during the experiment. So this is the diagram number 1. Diagram number 2, and lastly the diagram number 3.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic?
Hi guys, this is Bellaflores to tell you the procedure for this experiment. The first is to open the simulation link. Once the simulation has been opened, click and drag the circuit components from the sides of the simulation screen to get them into the work area. The parallel circuit will need 2 resistors only. Place the resistors and ammeters in a parallel form, then connect them using a wire. To measure the current flowing through a circuit and all its components, 3 ammeters must be placed in the circuit, meaning the current flowing through the parallel circuit must pass through the ammeters also. To measure the voltage supplied to a circuit component, 2 voltmeters must be connected across the component. Click on the resistors to change the resistant value in the experiment.
So once again guys, this is Bellaflores, your cutie little Einstein number 2.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic, Mel? Gumagana.
Hi guys, this is Mirador to present the table in this experiment. On the first trial, we have R1 with a value of 15, R2 with a value of 30, and RT with a value of 10. I1 with a value of 3.33, I2 with a value of 1.67, and IT with a value of 6.11, while V1, V2, and VT has the same value of 50. On the second trial, we have R1 with a value of 25, R2 with a value of 50, and RT with a value of 16.67, I1 with a value of 2.0, I2 with a value of 1, IT with a value of 4.11, while V1, V2, and VT has the same value of 50. On the third trial, we have R1 with a value of 35, R2 with a value of 70, and RT with a value of 23.33, I1 with a value of 1.43, I2 with a value of 0.71, and IT with a value of 3.25, while V1, V2, and VT has the same value of 50. So once again guys, this is Mirador, your cutie little Einstein number 4.
Hello guys, this is Princess Guardamano to present to you the computation of this experiment. So now guys, as you can see in our table, there are 3 trials. The numbers under the resistance number 1, resistance number 2, current number 1, current number 2, total current, voltage number 1, voltage number 2, and total voltage are the numbers that we encoded. While the numbers under the total resistance are the numbers that we computed. To get the value of the total resistance, we use the equation 1 over R12 equals to 1 over R1 plus 1 over R2. And the combined value will be changed into a reciprocal form to get the final value into a decimal numbers. For trial number 1, 1/15 plus 1/30 equals to 1/10. The reciprocal of 1/10 is 10 first, which is equals to 10 in decimal numbers. Trial number 2, 1/25 plus 1/50 equals to 3/50. In reciprocal form is 50 thirds, which is 16.67 in decimal numbers. And lastly, for trial number 3, 1/35 plus 1/70 equals to 3/70 in reciprocal form is 70 thirds, which is 23.33 in decimal numbers. So once again guys, this is Princess M. Guardamano, your cute little Einstein number 5.
Yo, yo, yo. Yeah. Mic check, mic check. Yeah. Gumagana ba to? Gumagana ba tong mic, Mel? Gumagana.
This is Florex from Magcanam and John Lawrence Layda to give our discussion and observation in this experiment. Unlike the previous series resistors circuit, in a parallel resistors network, circuit current can take more than one pass as there are multiple paths for the current. Then the parallel circuit are classes as current dividers. Since there are multiple paths for the supply current to flow through, the current may not be able to same through all the branches in the parallel network. However, the voltage drop across all the resistors in a parallel resistive network is the same. Then, resistors in the parallel have common voltage across them, and this is true for all parallel connected elements. So we can define a parallel resistive circuit as one where the resistors are connected to the same 2 points or nodes and is identified by the fact that it has more than one current path connected to a common voltage source.
The value of the measured voltage of the first and second resistors as well as the value of the overall voltage will remain constant in this experiment. The first and second resistors in the first trial are 15 ohms and 30 ohms respectively, with a total resistance of 10 ohms, while the value of the measured current of first resistor is 3.33 amps and the value of the measured current of second resistor is 1.67 amps with a total current of 6.11 amps. The first and second resistors in the second trial have values of 25 and 50 ohms respectively for a total resistance of 16.67 ohms, while the measured current of the first resistor is 2 amps and the measured current of the second resistor is 1 amps with a total current of 4.11 amps. The first and second resistor in the third trial have values of 35 and 70 ohms respectively for a total resistance of 23.33 ohms. The first resistor's measured current is 1.43 amps and the second resistor's measured current is 0.71 amps with a total current of 3.25 amps. So once again guys, this is John Lawrence Layda
and Florex from Magcanam, your cutie little Einstein number 6 and 7.
Yo, yo, yo. Yeah. Mic check, mic check. Yeah. Gumagana ba to? Gumagana ba tong mic, Mel?
Hello everyone, today I will be discussing our conclusion for this lab experiment. To sum up everything that has been stated in this lab experiment 6, we have concluded that in parallel connected resistance, the value of total voltage is equal to each voltage across the resistor. Also, we have noticed that the equivalent overall resistance is smaller than the smallest parallel resistor. So once again guys, this is Neil Anthony Cubid, your little Einstein number 3.
Hood